Hello everybody and welcome to another mystery box function challenge. In that purple mystery box there is some math and your challenge is to figure out what it is. You can use the link in the description to try this out on your own, and when you've got an idea, come on back and see if we get the same thing. All right, I'm going to start with a 0. 0 gives us 0. How about a 1? And that looks like a non-repeating decimal. It's close to 1/2. How about a 2? And 2, we've got a negative number that's also non-repeating. How about a 3? Yeah, definitely thinking trig here. We're getting up and down. Let's put in 3.14. And we're basically back at 0. So this is making me think of the sine function because it starts at 0, it goes up, and then it gets back to 0. It's funny though because it gets back to 0 sooner than I thought it would. So somewhere in here, like around pi over 2, let's put an approximation for that, maybe 1.6. Yeah, we're basically at 0 again. And I'm used to this taking until pi to get back to 0. Let me draw a unit circle here, and we can think about that. So, you know, for these trig functions, we put in an angle, and then we look at the coordinates where that angle intersects with the unit circle. So here we would have the coordinate 1, 0. Our sine is 0. A sine is always the y value. Up here at pi over 2, sine would be at its highest. So this is the point 0, 1. So sine would be 1. So that's at about pi over 2. Well, that's where we're back to 0 already here. And when we get to pi, we have the point -1, 0. So that's where we're back to 0. So this is making me think the frequency is faster. In fact, it looks like it's twice as fast, right? Because by the time we get to pi over 2, we're already at the value to expect for pi. So this is making me think we have a multiplier inside the parentheses on the sine function. So we'd have a sine of 2x. So let's just think that through with some of the other points we've got here. Actually, we could put in an approximation for pi over 4. So we could put that in at 0.8. Let's just use 0.8 as an approximation for that and see what we get. And there we're almost at 0.5, very, very close. So, and that looks to be the highest point this reaches. So at pi over 4, which would be right here, we're at the value we'd expect for pi over 2. Well, actually, we're not at the value, right? The value we'd expect is 1, and we're at 1/2. So I think we also have a multiplier on the outside. I think we've multiplied this by 1/2. So if we put in pi over 4, 2 times pi over 4, and then take the sine of that. Well, 2 times pi over 4 is pi over 2. The sine of pi over 2 is 1. And then we multiply that by 1/2. So 1/2 times 1, and you get 1/2. And that's what we're getting here at pi over 4. So I think that's what's going on. I'm just going to check a couple of negative values to make sure nothing strange is happening here. So let's put in a -1. And that's what I would expect. It should be going down there. How about a -1.6? And back to 0. Okay, so this looks like the sine wave is continuing there. So I think we've actually got this with the 1/2 times the sine of 2x. So that 2 on the inside makes the frequency of the function, it makes it go through that whole period faster than it would, twice as fast. And the 1/2 just reduces the amplitude, how much it goes above and below the x-axis. So I think we've got this. Let's go ahead and take a look. Yeah, 1/2 times the sine of 2x, and let's graph that as well. And there it is. So you get that typical sine pattern. It's just kind of squat and short because of the 1/2 multiplier, and it goes through that period a little bit faster because of that 2 multiplier on the inside. Well, how did that go for you? Did you get sine? Let me know. Thanks, everybody.